This topic is about linear inequalities, and then there are two major types. The first type is the inequality with only one unknowns. The second type is the inequalities involving not only one unknown, but we have another unknown together. So for one unknown case, it's a very simple situation. Is for example like x is larger than 2, then we use the graph to express this. That means we have one asset only, and then that asset is x because only x is involved, and then we need to have a boundary 2, and the region that we say fulfill our requirement is the right hand side region of 2. It's because we say x is larger than 2. So this is the graphical presentation for inequalities with one unknown. And then for another type with two unknowns, we are talking about like y is larger than x plus 2, something like that. Now we are going to compare two unknowns relation. So not only one asset, but we have another asset. Every point here representing a combination of x, y, let's say 2 and 1. And then the x, y combination is that fulfill the constraint here. If y is equal to 1, x equal to 2, then we have 1 larger than 4, which is nonsense. So this point do not fulfill the requirement here. Just now in the first type, we consider x equal to 2. That means we have a boundary here, and then our target may be right hand side or left hand side of this boundary. So similar situation. To identify what points xy combination will fulfill this requirement, we need to consider the equal case. And then we draw the line again. This is slope-intercept form, so it's very easily we can draw the line. X plus 2, that means slope is 1 while the y-intercept is 2. So it cuts the point here, and then we have a 45-degree going up line. This is y equal to x plus 2. Now we are finding any points the height is larger than x plus 2. So this is the equal case. Any point larger, higher, that means bigger y is here. So in this region, this is the region of y larger than x plus 2. Any point xy here, the y coordinates is larger than our boundary, that means at this point. And any point below that, we have a smaller value of y compared with our reference. So below our reference is the y, that means the height smaller than our reference. Y smaller than x plus 2. Any point here will fulfill this requirement. For example, like if I say 0, 3. If 0, 3 fulfill the requirement, you may put it inside. Then we have y is equal to 3. X plus 2, that means 0 plus 2, that means 2. Then in this region, we find that y is larger than x plus 2. Again, if we choose 0, 1 to test the situation, y and x plus 2, y equal to 1, and then x plus 2, that means 0 plus 2. So we are comparing y and 2 here. Then we will find that right hand side is larger than left hand side. So that's how you identify the region, is that larger than or smaller than. But one of the key points is you have to write in terms of slope-intercept form. Otherwise, no matter drawing the lines or identify the region will be much more difficult. In this case, we are finding the region which fulfill this constraint, y is larger than x plus 2. That means above our reference. So we are talking about this region. All the points in this region will fulfill the requirement. But the same, if it is equal case, we use a full circle. However, if we do not include the equal case, then we can't use solid line. We use dotted line instead to represent the situation that we do not accept equal case. In real world, rather than equations, but usually we are handle some constraint which is inequality. For example, like the total cost can't exceed a certain amount, something like that. if we can have enough constraint, maybe we have limited choice of the point fulfill all our condition. But if we're just talking about one criteria here, then you'll find that you have infinitely many choice here because this region is not bounded. In the real world application, maybe we are talking about x and y is positive, so we can only select this region. And then later on, we give you one more constraint. For example, like this, the total cost can't exist this, so we are talking about downward. Then we can only choose the region, which is limited within this triangle. Anyway, mathematically, you may still say that you have an infinity many choice because I didn't say that it must be integer. Then there are infinity many rational number or irrational numbers. But if I give one more constraint, which is about this is the integer, x and y are integers, then we have limited choice here.